This is a lesson for Year 10 Higher Mathematicians on summary statistics, and it's lesson 2, mean from a grouped frequency table. The heights of the sunflowers grown by a class of children are recorded below. Decide on class intervals and place the unsorted data into a grouped frequency table. Explain how to decide a suitable number and width of class intervals. Right, now there are some basic rules that you need to use when dividing the data up into class intervals. As a guide, you should have 5 or more class intervals. The intervals can be of equal width, but they don't have to be. And just to make a point about that, I'm going to use unequal class intervals when I complete this table in a moment. So the first one I'm going to use is 75 up to 95 centimeters. Now, how I've written these inequality symbols here is quite important because it tells me where a flower that is exactly 75 or 95 centimeters tall goes. Now, this means that 75 and above can go in here, so a sunflower that's exactly 75 centimeters would go in this class interval here. However, a flower that measures 95, we could have anything up to that, but not including it. That's what this inequality symbol tells us. The 95 centimeters is going to go in the next class interval. Now, similarly, 105 centimeters, we can have up to that, but not including it. So a sunflower that is 105 centimeters tall would have to go in the next class interval. There we go. Now, as I've said, you'll notice that they are not of equal width. This is 20, 10, 10, 5 and 5. It's not a problem, but there do have to be at least 5 class intervals in total that you've split the data up into. If you have less than 5, it becomes oversimplified, the data that you've collected. If you have too many, well, what's the point in coming up with the class intervals in the first place? It's got to be a sensible number to reflect the data that you're collecting. Now, in the previous lesson, I went through and completed the tallies. I'm not going to do that today. However, the frequencies, if you wanted to go through and do that, you could. If you wanted to check, then you should have 7, 11, 6, 3 and 2 in total if you've gone through and done that correctly. And looking at this example, the group frequency table shows the masses in kilograms of the fish caught by an angler one day in April. Find the modal class, the estimated mean, and the estimated range. Okay, so what we want to do then is, very much like the previous lesson, use the frequency table to find the summary statistics. In this case though, the frequency table has grouped data. So the modal class doesn't change a lot, okay? So the modal class, we're looking for the most common mass of the fish that were caught in April. And as we can see, looking down the frequency column, 9 here, that tells me the modal class is going to be between 8 and 10 kilograms. Now, the estimated mean causes us a little bit more of a problem because we don't have a single value for the mass of each of the fish. we have a class interval. And this is why it's going to be estimated as opposed to the exact mean. So if we've got a class interval that runs from 2 to 4, well, the fish in there, we could have 5 fish that are all 2 kilograms, or we could have 5 fish that are all 4 kilograms. We don't know. So what we're going to do is we're going to take the midpoint of that class interval to represent all the fish, and we're simply going to multiply that by the number of fish. So the midpoint of the class interval 2 to 4 is 3. 5 times by 3 tells us that the mass of the 5 fish in that class interval is approximately 15 kilograms. And if we work out the midpoint of each of these groups, that will allow us to then come up with the estimated mean. So here we've got between the midpoint of this class interval 4 to 6, 5, 6 to 8, therefore midpoint is going to be 7. 8 and 10, the midpoint is going to be 9. 10 to 12, the midpoint is going to be 11. So now we can calculate the value of f of x to complete this column here, and then find the sum of f of x. Okay, in other words, the sum of the weights of all the fish that were caught. So 8 times by 5 gives me 40. 4 times by 7, 28. 9 times by 9, 81. And 3 times by 11, 33. And all those add up to 197 kilograms. So the mass, the estimated mass of all those fish is 197 kilograms. We don't know the number of fish that were caught, but if we add up all the frequencies and find the sum of the frequencies, that should tell us the number of fish that were caught, which was in this, here it's 29. Therefore, to find the estimated mean, we simply need to do 197 divided by 29, which gives us a value of 6.8 kilograms. Now, for the estimated range, we don't know the masses of the fish in between 2 and 4 kilograms, and we don't know the masses of the fish in between 10 and 12 kilograms. So what we do is say, well, the heaviest possible fish in this group could have been just under 12, we'll take it to be 12. And the lightest possible fish in this group could have been 2. Therefore, we come up with an estimated range of 10 kilograms. Now, the reason we find all these summary statistics is to allow us to make a comparison. And here, we're being asked to complete the summary statistics and compare days in April and June. Well, I've already completed the summary statistics that we've just found out for April. And here we can see the summary statistics for June. So remember, if we want to make a comparison, we need two things. We need a measure of location, which is an average, and a measure of spread, which is the range. So I'm going to look here again. I'm going to use the mean because that's what we were calculating today. If we have a look at April compared with June, we can see that in April, the fish are on average about half a kilogram, 0.5 kilograms lighter than in June. So I'm going to write my first comparison. On average, the fish in April are 0.5 kilograms lighter than June. Okay, and that there is my my comparison of the measure of location. Now I need to have a look at the measure of spread, which means looking at the range. And I can see here that the difference between the highest and lowest values in April is more than in June. So that tells you the results in April are more varied. Therefore, I will say the masses of the fish in April are more varied than June. And those two comments are all I need to compare the days in April and June. And just remember, you can say the same thing in another way. So you could say the masses of the fish in June are less varied than April. On average, the fish in June are 0.5 kilograms heavier than April. But as long as you've got those two comparisons, the measure of location and the measure of spread, you will have fully answered the question.